Right, now I'm going to do some calculations on reacting masses for you, and I would be hopeful that you would kind of make a note of the year now, please, in the question. And after this video, I'd want you to go back and try it yourself. If you watch me going through it, it does help, but I would like to think that you were going to work your way through this. Now, every year there's a half question on this style, and they'll give you a full balanced chemical equation, they'll give you one quantity, and they will ask you various questions about it. Now, these are very reliable marks if you work on them, and I hope you will. You could really score very high in these with any bit of application at all. Now, I'm conscious that the print here may not be too clear. This is 2014, question 11b, okay? Will you be aware of that now, please? 2014, question 11b. Question 11b, okay? Make a note of that, please, and in your own time, you could be dealing with it, but I'm going to read through it with you now, and I'm going to ask you to be aware of the kind of anomalies. Now, I'm picking these questions. We'll do 4 or 5 questions here now, but each of them has a sting in the tail somewhere or other. Be careful. This is one of the more straightforward ones. When crystals of ammonium dichromate, and they give you the formula for ammonium dichromate, are heated strongly, they decompose according to the following equation. So they've basically introduced you to this equation. They've given you a sense of it, and that's what it's about more than anything else, that you're alert to that, okay? And you have a given balanced equation there. Next thing it says then, when 12.6 grams of these crystals were heated strongly, calculate 1, 2, 3, and 4. Now, folks, with all due respect, you have to see there are 25 marks there going a begging. You could score very high on this. You get full marks on this very easily. There's a lot of control over these questions, and I'm a great believer in that. Doing questions where you have a lot of control. So I have to handle that for you now. First thing we have to do is transpose the equation onto your manuscript. That's NH4. NH4 twice Cr2O7, that's ammonium dichromate, going to Cr2O3 plus N2 plus 4H2O. Now, please, every time you're doing one of these questions, please check that you have everything down correctly. Ammonium dichromate, 1. Chromium oxide here, 2. 1 of that. Nitrogen is next, and 4 there. That's good. It's all in order, right? There's no problem there. And it told you clearly that there were 12.6 grams. Written in the next line, 12.6 grams of that stuff. And they asked you various questions about the equation now. Now, folks, if there's only one reactant, it has to be the limiting reagent. It's the only one that can run out. And that's exactly what you do. It is the limiting reagent. You have nothing to worry about there. That's all you're dealing with. There'll be nothing to it, okay? And that's it. So that's the limiting reagent. So let's set up the mole strip. That's the limiting reagent, okay? So here we go. The ratio strip is 1 to 1 to 1 to 4. And the moles strip okay, you convert that to moles. Okay, be careful now, please, that you get that relative molecular mass right. The MR for that is 252. You're dividing 12.6 by 252. Now, please be careful that you wouldn't make a mistake with that. Go back and do it yourself now. Nitrogen is 14 and 4 is 18, 2 18s. You have 2 chromiums, be careful. And you have 7 oxygens, okay? 252. And that comes out to be, what did I tell you many times already? They will have cooked that figure so that you get a nice rounded number, okay? You'll find you get a nice rounded number there. That was selected so that will give you a rounded figure there, and that's exactly what it does, okay? And so here we go then. That's 0.05, that's 0.05, and that's 0.20. Everybody okay with that? Now, you can answer any question based on that. I hope you're thinking now that this would be a soft question. Okay, and the questions are as follows then. How many moles of ammonium dichromate reacted? There's the answer. Okay, that's the first answer, 0.05 moles of ammonium dichromate. You write it down like that in the exam then, 0.05 moles, right? Ammonium dichromate, NH4 twice, Cr2O7, ammonium dichromate, right? Now, please be very careful, won't you, that you answer the question you're asked. A number, okay, a unit and a tag. Very important that you're writing like that. Next, What mass of chromium trioxide? Now, please put up with me. That's called chromium trioxide because the oxidation number for chromium is 3. I will be doing oxidation number in the near future with you, and we will deal with all that then. Just take my word for it for the moment, please, that that's how it is, okay? That's the compound anyway, okay? And it does say there, by the way, look, what mass of ammonium dichromate is formed. So it has to be on the right-hand side, says that one, right? It's the only chromium on that. Okay, what mass is formed? So you take that many moles, 0.05 moles, okay? And that's equal to 0.05 multiplied by the MR for that. The MR is 152, okay? And the answer you're going to get there is 7.6 grams. And please tag it as chromium Cr2O3. Now, please be careful that you won't make a silly mistake here. The mistakes you make here now have nothing to do with chemistry, and they have everything to do with just having good method and good structure and being aware. And if you are, you'll do very well. And that's what they require from you. That's the second one. The third part, what volume at STP of nitrogen gas is produced? Nitrogen gas, what volume? 0.05 moles equals 0.05 multiplied by 22.4 litres, okay? And that's your answer. The answer comes out to be 1.12 litres, 1.12 litres. Please tell me the name of the gas, N2, okay? Very important. The number of molecules of water produced. There's the number of moles of water. So the number of molecules is 0.20 moles. Water, H2O, equals 0.20 multiplied by 6 by 10 to the power of 23, and that gives your answer, and your answer comes out to be 1.2 by 10 to the power of 23. And there was a last part to it. How many atoms did that quantity contain? Every water molecule has 3 atoms. 2 hydrogen, 1, multiply that by 3, and you have your answer, okay? 3.6 10 to the power of 23. That was 2014 now, guys. Will you be aware of that, please? Okay, that's relatively recent. So, you know, you do once in a while get a gift horse like that, and you must be ready to exploit it. Okay, and question 10 and 11 is where it normally comes up here. It could come up anywhere in the paper, but 10 and 11 usually guarantees you a 25 marker there, all right? And that's very important you follow that up. So that's your first question. I hope that's okay. Now I'm going to go through several of them because they're not all quite as straightforward as that. I just needed you to have a sense of where you're going with that, and that's what I'm doing. Okay, I'm going to go back a bit now because I want to find various problems along the way that we need to solve. This is 2004, question 10, 10A. Make a note, please. 2004, question 10A. Now, this one is different in that the quantities given vary from what we normally get. And I want you to be careful now. You must be adaptable here, whatever you're going to do, okay? This is 2004. 2004. And it's question 10A. Question 10A. Okay, and this is it here. I'm reading through it now for you. It reads as follows. Hydrochloric acid is severely corrosive to skin and eyes and toxic by inhalation or ingestion. It should be handled carefully and stored safely. And then they proceed to tell you that a bottle of it was spilled. And basically that's what the question is about. The entire contents of a bottle containing 2.5 litres of concentrated hydrochloric acid were accidentally spilled in a laboratory. The spilled acid was neutralized by adding solid, powdered sodium carbonate. And the neutralization reaction is described in the following equation. You're given one full balanced chemical equation. Okay, you must surely feel a mole strip coming on. Okay, and here we go then. Na2CO3 is the sodium carbonate, plus 2HCl, that's the acid that was spilled, and it was converted to NaCl plus H2O plus CO2. And let's see it's down correctly. I have 1 to 2. Be careful, please. There's a 2 there. There's a 1 here, and there's a 1 here. Very good. Okay, and we have that. That's our balanced equation. Now, before I go any further, can I just say to you that you need to make sure that you're taking this down correctly, and you do it every time. Okay, there's no question of working with anything from the question. The spilled acid was 36% WV. of hydrogen chloride. Now, hydrochloric acid is hydrogen chloride gas dissolved in water. I'm saying that again to you now. Hydrochloric acid is hydrogen chloride dissolved in water. So it's a solution. And they gave it the concentration. They gave it to you as 36% WV. Now, folks, I had a rant earlier on in these videos about you having to know the mole and having to know the road map in the case of volumetric, how you go from one concentration to another, and so they've given us this concentration here. Now, what they've told us is this, and we better just think about what's happening here now. Somebody spilled a significant amount of acid in the lab. Now, that would be quite serious, and I'm suggesting to you, you would need help in mopping that up. That would be very dangerous, okay? And so ultimately, you would ask, how you would mop it up is you would throw this substance called sodium carbonate, harmless stuff, sodium carbonate, on top of it. Acids and carbonates always give you a salt, carbon dioxide, and water. You have this very dangerous acid, you pour this powder on top of it, you'll mop it all up, you'll use it all up, and you'll end up with a harmless salt, which you can put on your dinner, by the way, water, and carbon dioxide. So there'll be nothing corrosive in the products, and that's exactly the whole idea, right? That you mop this up. So that's going to be in excess, and that's going to be the limiting reagent. Now, guys, you need to stop now and ask yourself, would you have known that? If you had spilled this acid on the floor and you needed to get help with it, the person that's going to bring the sodium carbonate to you is going to say, well, how much acid did you spill? Because I'll need more than that sodium carbonate to mop it all up. That's all going to be mopped up. Now, I can't teach you that. I must say that again to you now. The limiting reagent is the one that runs out. And they decided they needed to mop up all the acid with this stuff. So that'll be in excess, and that'll be the limiting reagent. Now, I have to get you to think about that just in terms of what you're actually doing, and you won't have any issue with it then if you do. Now, the situation is this. That is the limiting reagent, and we were given the quantities. The quantity we were given, and I have to look it up for you again now, is 2.5 litres. That's a hell of a lot of acid. And its concentration is 36% WV. 36% WV. That's the quantity you're given. Now, why I'm doing this question is because here we go. You got a full balanced chemical equation and you got one quantity. But the quantity you got was not a mass. I didn't say you'd always get a mass. You were given one quantity, and because it's a solution, you need to know both the volume and the concentration to get the number of moles. We need to convert that into moles to make up the mole strip. Now, this is a very good example of where they vary the question a bit to see who understands this properly. Okay, and I'd ask you to be sensible for this now. Okay, and that's most important, we fill this out. Okay, so you're given that. Now, can I remind you of something? For solutions, moles equals centimeters cubed divided by 1000 multiplied by molarity. Now, sorry, I'm just checking my camera to see, are you seeing that on the screen? You are. You're okay with that? You can read it correctly. You're all right. Yeah, that's good. Okay, so you have that. Right, moles equals centimeters cubed over 1000 by molarity. Now, we must get the volume and we must get the concentration of molarity to get moles. So here we go, right? The volume is easy, 2.5 litres. I'll put that in there in a moment. What about the other one? Here you go. 36% WV. Do you know what that means? W is weight, V is volume. It's 36 grams per 100 centimeters cubed. Okay, so that would be 360 grams per litre. And you'll go to moles per litre next. Are you okay with that? Divide by the MR, divide by 36.5. That's 360 divided by 36.5. And that's going to give you moles per litre, okay? Moles per litre. And I got for that 9.86 molar or moles per litre HCl. Okay, that's molar, that's moles per litre. Are you okay with that? Now, that's your roadmap. You went from percent WV, are you visualizing this, to grams per litre. You had grams per 100 is percent WV. That's grams per litre, okay, multiplied by 10. And then moles per litre divided by the MR. Do you see it's 9.8 molar? That's some concentration. That's highly concentrated acid. Remember what you normally use in titrations is 0.1 molar, so that's highly concentrated, okay? But it's going in there anyway. That equals, be careful, okay? 2.5 over 1000 multiplied by 9.86. And can you see the disastrous error I've made? Okay, there's the molarity there. Okay, that's litres. Give me a break. It says centimetres cubed. Okay, so you must be very careful. 2,500. Okay, and you're going to get the moles out of that, and the moles came out to be 24.66. 0.66 moles. Okay, and I have that done. Now that was a little journey, but of course, can you see that the whole question was dependent on it? Now that's where your chemistry excels. If those basic units back here about converting to moles and your mole strip are tied in with this whole thing of, of your concentrations. You can't just now, you must go back on this now, and you'll be brutally honest with yourself here now. Would you have got that right? Okay, there's the quantity they gave you. There's no point knowing the volume of a solution if you don't know its concentration. There's no point knowing the concentration if you don't know the volume. You have to know both to get the number of moles in a solution. I'm going to leave that there for the moment. You have to get both the volume and the concentration if you're to get moles, all right? And that's exactly what we're working with. So here we go then. I'm going to set up the ratio strip and the mole strip as follows. Ratio for a start, 1 to 2 to 2 to 1 to 1. Moles, and you must convert that to moles, okay? And I got the answer there, didn't I? 24.66. So that's going to be 12.33. And that's going to be 24.66, 12.33, and 12.33. Okay? And so now, can you see? It's all very important, but as I've said to you so many times already, if that number is wrong, then what follows is a disaster. So please, will you be careful? I mean, no matter how we go about it, that's very important. I don't think I need to do any more with you because if you got that right, you'd be on your way. But anyway, let's read the question. The spilled acid was 36% WV solution of hydrogen chloride and water. Okay? Calculate the number of moles of hydrochloric acid spilled. And that was that. They were giving you a reasonable reward for that, look. 10 marks for that. That someone could convert that to that. And rightly so. Because that means you're very good at chemistry. Okay, now please be careful, okay, there was 10 marks for that alone, and the mole strip I've constructed from that, and as a result now I'm going to work the rest. Calculate the number of moles of hydrochloric acid, 10 marks. What was the minimum mass of anhydrous sodium carbonate required to completely neutralize all the spilled acid? There's the minimum amount you need. There'll be more than that there, but that's the amount you need. Take that many moles and multiply by the MR for sodium carbonate. I think the sodium carbonate has an MR of 106. Multiply that by 106, and the answer you're going to get is 12.3 multiplied by 106. And I got for that 1303.8. Okay, now that's good. Grams, of course. And sodium carbonate, Na2CO3. I got it from there, okay? Very important, right? I got it from there. Right, that's that one, and and you can see you're getting 9 marks there. And lastly, you're asked, what volume of carbon dioxide in litres? What volume of carbon dioxide in litres, okay, at room temperature and pressure was produced in this neutralization reaction? They didn't have to say room temperature and pressure there, be aware of that. Okay, they have to say STP if they mean STP. They don't have to say room temperature and pressure. Will you be aware of that, please? Okay, and they did anyway. So you take that many moles, that's 12.33, and multiply it by room temperature pressure, 24.0 litres. Okay, and there's your answer. Okay, came out as 295.2 litres of carbon dioxide. Okay, there's your answer. Now, very good. Now, I hope you can see the divergence in that one. It was different to the others in that it threw something else at you, and you have to be careful with that. Okay, I'm going to move on. I'm going to do another one with you. There's only a segment of this one I'm going to do. This is 2006, and it is question 11b. Question 11b, okay? Now, please now, will you make a note, please, of the year, because I appreciate very much that sometimes on your screen you can toggle your video back and forward, but you may not be able to read all the data here, and that will be a problem. But well, now let me get this right for you. This is the one I want, sorry, it's part A. 2006, 11A, right? And most of this I've done already. I won't hang around with it. It's the last bit I need to do with you, but it would be important that you have a sense of where you're going with that. Now, one quantity, I've told you already, doesn't always mean it's one quantity in grams, so be careful how it's presented to you. What is an ideal gas? I'll take it you could tell me that, okay? It's a gas which obeys all the assumptions of kinetic theory under all conditions of temperature and pressure. Give one reason why a real gas, like carbon dioxide, deviates from ideal behaviour. Now, you've that done already with me, so that should be fine, okay? Carbon dioxide molecules occupy space. Okay, carbon dioxide molecules have intermolecular bonds between them, but you'd want to tell them what they were. They're van der Waals forces because carbon dioxide is non-polar. Okay, good. Any one of them would have done. Assuming ideal behavior, how many moles of carbon dioxide are present in a volume, a temperature, and a pressure? Okay, PV equals nRT, and you're finished. You have a volume, a pressure, and a temperature, and you're looking for the number of moles. Okay, how many moles? Okay, next. This is the next bit I want to get at to show you how they mix their questions. The reaction between carbon dioxide and lime water is represented by the following balanced equation. Okay, represented by the following balanced equation. So we need to look at that. I'm going to take it down for you. Calcium hydroxide is lime water, by the way. Did you know that? That's lime water, yeah? And you bubble carbon dioxide through it normally to test for it. That's one of the tests on your course, by the way. Test for carbonates. When you pour acid into any carbonate, it will start effervescing. It'll produce a gas, carbon dioxide, and you prove it's carbon dioxide by bubbling it into lime water, and it turns milky. Why does it turn milky? Because one of the products is not soluble. And of course, the product we're talking about is that. That's calcium carbonate is not soluble, and it's all 1 to 1 to 1. And what did the question ask you now? The reaction between it is represented by the following equation. What mass of calcium hydroxide is required to react completely with the quantity of carbon dioxide given in 2 above? Now, you had to get moles from 2 above, okay? That was the point, that you went away and had to do that calculation. That's very important, right? So you did your PV equals nRT, N equals PV equals nRT, PV equals nRT. Are you okay with that? So N is equal to PV over RT. So you've gone away and done that already. And it came out as I got an answer of 0.03 moles of carbon dioxide. Okay, so here I go again. Ratio strip. 1, 1, 1, 1. That's correct. And you're being asked a question here, okay? What mass of this will react completely with the quantity of carbon dioxide? React completely. So that's the limiting reagent. It reacts completely. There's none left, okay? Limiting reagent, okay? And now, but you happen to know that this one here, now, the carbon dioxide is the one that reacts, okay? What mass of this reacts completely with the carbon dioxide? All the carbon dioxide is going to be used up. Okay, so 0.03 is, that's not correct. That's the limiting reagent. How much of that will you need to react with all of this? But I'll say that again to you now. Okay, the wording there is a bit unusual. What mass of calcium hydroxide is required to react completely with the quantity of carbon dioxide gas given above? So you have a given quantity, okay, and it must react completely with that. Okay, so that's 0.03, that's 0.03, that's 0.03. As it happens, the only one you need is that. Okay, so there is your answer. There is your answer, moles of that, and you must multiply by the MR. Okay, that's all. There's nothing else to it. 0.03 multiplied by, be careful there please, 74. Multiplied by 74, and that equals 2.22 grams of calcium hydroxide. Now please don't cut corners here. You'll be tempted here now not to bother with that and that. I understand that, because that could be very often these questions, these half questions, are set as full questions and they're truncated. So there could have been other parts of that question that they decided in a given year to leave them out, okay? So just be careful of that now. There was. I would still I would still, if they give me an equation and they give me a quantity, I'd still use a mole strip. Don't feel always that, that's easier, I can do that another way. Be careful. You'll have it done while you're thinking about it, and that's very important. Okay, I've that one done. And now, I need to be careful here that you are following this up with some kind of order, and I'm going to do this one with you now because it's very, very important that we do something that appears complex but isn't complex at all. This is 2017, question 11A. 2017, question 11A. Now, you are not, the reason I'm doing this is now because some people are intimidated by particular equations. And there's a feeling that, there's something difficult about them because the chemicals have not been seen before or because they're unusual in some way. I'm going to read through it with you now, and I'd like you to spend some time on your own doing it again. I'd like to think you take an A4 pad sometime, open this question and proceed to set up the answer and come up with the questions and come up with the answers to it, having constructed it appropriately. Some of the blue pigment, azurite, used by an artist in a picture painted in 1600 has changed over the years into green malachite according to the following balanced equation. There's the blue pigment. Now don't worry about it, you're given the full molecular formula. And there's the green one then that forms on it over many years, right? And it goes on to tell you then that analysis shows that the only copper-containing pigments in the painting are azurite and malachite, and that the picture contains 3.81 grams of copper. Are you thinking immediately that you could convert that to moles? Okay, that's very important. They give you grams of a named substance. You could convert that to moles readily if you wanted. Now, please, I'm saying it again to you now. If you are doing this section and you think that that's a tough question, but the other one was an easy question, then you do not have a reliable method. Your reliable method means it doesn't matter what they present you with, they've given you a full balanced chemical equation and they've given you a quantity here which we can work with. And that's all that we need, nothing more, nothing less than that. Now, they tend to turn things on their head a bit to see, are you rote learning this or do you have a good method? And that's where you must excel now. And I'm asking you to work your way through that. If you do, you'll be fine. There'll be no problem with it, right? Okay, so just bear with me now while I pull this together for you. What mass of pure azurite contains that many grams of copper? So we've that many grams of copper. You need to divide that by 3.81 divided by 63.5, he says. Yes, isn't that right? 63.5, and you'll get the number of moles, grams, you'll get the number of moles of you want from that. And so that comes out to be 0.06 moles of copper. And the question they've asked you as a leading question, what mass of pure azurite contains that many grams of copper? That many grams of copper is that many moles of copper. Now, you must look at the formula for azurite. I better write it out for you now so that we have everything here. Okay? Now, don't be intimidated by the formula. CO3 twice, OH twice, and they told you it's a solid. That might be useful later on. It's a solid, right? Plus H2O, and that goes to Cu2, CO3, OH twice. And there's carbon dioxide at the end, of course, carbon dioxide. Now, I hope I have the formula done right. Please be careful that you get everything down correctly here, okay? 3, 2, OH twice, yes, and H2O, copper 2, CO3, OH2. Now, and that's good. And the balancing numbers, I have a 2 in here and I have a 3 in there. Now, please pay particular attention to this. There's many sad stories about people very good at chemistry screwing up with little things like this. Now, we'll talk about the names later, but that's it. Now, the statement they've made here is now, what mass of that stuff, of the stuff here on the left, okay, contains that many grams of copper? If it contains that many grams of copper, it contains that many moles of copper. Now, look at that molecular formula, okay, and you will see very quickly there are 3 coppers in every molecule. So if you have that many moles of copper, you must have 0.02 moles of azurite. Do you mind if I write the name because it's shorter than the formula? Okay, azurite, which I've told you there. That's azurite. Now I'm going to say all that again to you. It asks you clearly what mass of pure azurite, if you had pure azurite, what mass of it would contain that many grams of copper? That many grams of copper is that many moles of copper. And you look at the formula and say there are 3 coppers in every molecule. So you'd have to divide by 3 to get the number of molecules of azurite. And there's the number of moles, divide that number by 3, 0.02. And of course, that will be a determining factor when you go to do the rest of the calculation. Calculate the maximum mass of malachite that will eventually be formed from this mass of azurite. Now, folks, you must read the question correctly. From this mass of azurite. Okay, now I haven't answered the question yet. I've only got the moles. That's moles of azurite, and I have to get the mass for you. Okay, 0.2 moles. You have to multiply by the MR, and I got 6.89. Now, will you be careful, please? That equals 6.89 grams of azurite. Okay, you have that many moles, so that many moles of azurite, very, very important. All right, the MR for that, I have made a note of it here, is 344.5. Okay, 344.5. Okay, and the 0.5 has come from the fact that copper is 63.5, and you have 3 of them there. Okay, just be careful, that's the MR for that. All right, so the mass of azurite, here, I'm writing it down for you now, is 6.89 grams. That's what they were looking for. Okay, and I think I better just recap on that again now. This is not difficult now. You just need to make sure you're answering what you're asked. It's not that you wouldn't be able to do this, but you'll misrepresent what you're being asked. They told you that this is a blue pigment present in the painting, and over a period of time it turned to green. Okay, and they told you the only 2 sources of copper are there and there. That's for something to follow, right? And they went on to ask you then, analysis shows that the only copper containing pigments is azurite and malachite, and that the picture now contains that many grams of copper. And then they asked you a separate question. What mass of pure azurite contains 3.81 grams of copper? Grams of copper, moles of copper. Every azurite has 3 coppers in it, so you must divide the number of moles by 3 to get the number of moles of azurite. And then multiply by the MR, that monstrosity. Multiply by the MR to get that many grams of it, okay? So that's grams of that. I'm going to make out the mole strip for you now. Ratio strip 2:1:3:1. Right, I'll get rid of this again. And there's your mole strip now. Here we go. Moles. And I'm converting that into moles here, okay? Because it's going to calculate the maximum mass of malachite that will eventually be produced from this mass of azurite. So that's your limiting reagent, this mass of azurite, that's the limiting reagent, okay? And we already know, of course, don't we, that the number of moles, that's 0.02 moles. 0.02. Are you okay with that? 0.02 moles, right? So if that's 0.02, that's 0.01, that's 0.03, that's 0.01. And the question is asking you to calculate the maximum mass of malachite that can eventually be formed from this mass of azurite. That mass of azurite, that's the number of moles of malachite, and you must multiply it by its MR. So it is 0.03, that compound we're talking about now, moles of malachite, okay, I'll just put mal in there, okay, is equal to 0.03 multiplied by the MR, 2 to 1. Be careful now, please. 2 coppers, 1 carbon, 3 oxygens, OH twice. Be careful, please, right? And that comes out to be 6.63 grams of malachite. 6.63 grams. Now, I'm saying it again to you. I know I'm repeating myself now, but sometimes there's a perception because the compound is awkward or difficult that the question is more difficult. It's the same method. Now, please, I want you to grow in confidence about this, that like there's nothing difficult about that. It's an original molecule they're giving you, okay? And just be careful with it, right? So the ratio, that allowed you to get that. And now you have that many moles of malachite, multiply by the MR in your grams, and there's your answer, okay? There's your answer. There was 9 marks for that. 9 marks for that. Next. What is the volume measured at STP of carbon dioxide that would have been released from the painting in the formation of this mass of malachite? This mass of malachite, here we go again. So you're down to here, that's moles of carbon dioxide, and they've asked you at STP, multiply that by 22.4 litres, and you're finished, okay? The answer is 0.01 multiplied by 22.4 litres of carbon dioxide. Okay, and that's that answer, that's fine, and there's 6 marks for that. Suggest a way, and that's it, forget the calculation. Suggest a way that further deterioration of the painting by this chemical reaction could be prevented or delayed. Now, what's very important here, and I'm tipping you off of this, you have to get a bit streetwise here now, is that sounds very technical, but look at this, the reward. 1 solitary mark. They weren't looking for much. Okay, how would you preserve? What has happened to that painting? Over the years, the moisture has affected it and converted it from the blue to the green. So how do you think you might prevent it from further deterioration or decay? And the answer is, of course, keep it dry. That would have got to the mark, by the way. And many of them would do, okay? You could varnish it. You probably know, do you, that many paintings are varnished, okay? Just to keep the moisture away from them. Low humidity, keep it in a cool place. Any of those, but the dry aspect of it, keep it away from water, keep it dry, will get you full marks. And that's that. Now, I've deliberately shown you that one because I want you to see what's involved. I think it's important that everybody has a sense that, you know, you could get any equation, but once you have a method, you'll be able to work well on it. Now, I'm going to break it that because I think you'll need to kind of work on those few first now and see how you're handling them okay. And I'd like you to do each of them in turn if you would.